Here's our unit circle review. So what is so special about the unit circle? The word unit there implies the radius of our circle is 1. So all these have a radius of 1. And what are the key features? So here's what I want you to focus on. The unit circle actually gives you the sine and cosine. But how does that work? How do you get sine and cosine from that? Well, you see if you draw an angle, so we'll call that angle there theta, you produce a triangle, and it has an x component and a y component, or you can call it adjacent and opposite if you wish. Now, how does that help you at all? Here is how it helps you. If you were to take a ruler and literally measure the length of that green line, the x-coordinate of that triangle, that would be the cosine of theta. That's how the unit circle is special. That distance is the cosine of theta. Now, if I were to measure that side of the triangle, the opposite side, the length of that would literally be the sine of theta. Okay, it's true for all four of these. So it gives you the sine and cosine. You could just measure the length. But I want you to notice something here. If I were to measure the length of this side, that also would literally be the cosine of theta. But here's what I want to point out. You're going to the left. On the left side, if you measured and took the coordinate there, the cosine would be negative. So that's the next big key. The unit circle gives you the sine, S-I-G-N, plus or minus, of the sine and cosine. So clearly from here, since the x is negative, the cosine would be negative here. Here, the sine, it's positive because it's above, it's going up. So the sine would be positive in that quadrant. So that's why I'm going to show you why this is valuable. In the third quadrant, this cosine here is negative because you're moving left. X is negative. And you're moving down for the length of the y, so your sine is negative. So you don't have to memorize that. All seniors take civics stuff, and it's better not to. You just should look from the picture knowing cosine is the x-coordinate, sine is the y-coordinate. You can just look. Oh, y is negative down there. Sine's negative. Oh, x is negative here. Cosine's negative. So it makes it much easier. And here, if your angle's in the fourth quadrant, look, cosine's positive because it's to the right. To the right's positive. Sine is negative because down is negative. So quick summary to look at this. If you want to know whether the cosine's positive or negative, this is the separation. On this side, the cosine is positive. Why? Because x is positive to the right. And on the left side here, cosine is negative. Why? Because to the left, x is negative, so therefore cosine is negative. Much easier to deal with than trying to memorize. All senior takes civics and figuring out what that means. Now for the sine, sine is the y-coordinate. Where is the y-coordinate positive? Above the x-axis. So sine is positive on top, and sine is negative below, because again, cosine's the x-coordinate, x positive to the right, x negative left. Sine is the y-coordinate, y positive above, y negative below. So it makes knowing sine and cosine, the sign of it, positive or negative, very easy. And if you want to do the tangent, it's just sine divided by cosine. So, for example, right here, cosine's negative and sine's positive. So tangent, a negative and a positive gets you a negative, so you know the tangent's negative in that quadrant. So that's how you're going to get whether something is positive or negative, sine, cosine, or tangent is positive, negative in each quadrant, instead of memorizing that silly all seniors take civics. The next thing you have to master are the special right triangles. The first two are easy, and you just have to memorize this. This is one of those things that in general I don't like memorizing, but this you just have to memorize. And when you do enough of these, it becomes very natural. So 30, 60, 90 right triangle. There's your relationship between the three sides. And I'm going to call it radical 3, 1, and 2. So we just set this as 1. We know the hypotenuse is twice the size of the shorter leg. And the longer leg is radical 3 times the shorter leg. So these are the ratios. Now, truly, to get a unit circle, this would have to be 1. To make that 1, I divide all of these by 2. So I get 1, 1/2, radical 3 over 2. That's fine. But let me move this radical 3. I rather just memorize this in my head, this triangle. So I literally see this triangle. When I see this, I know radical 3 is the biggest one, or bigger than 1. So I know it's going to be a wider triangle, so it must be the 30. Now, if you look at this, 60, 60, 30, 30. These are the same triangles. They're just switched. So the 1 is here, and the radical 3 is here. So when I do these in my head, this is how I visualize it. Radical 3 is bigger. This is going to be the wider, flatter triangle, must be the 30. Here, radical 3 is bigger. It's a taller triangle. The taller one's going to have a bigger angle. That's the 60. And the last one we have is the 45, 45, 90. This is an isosceles. So that's 1, and that's 1, and this is radical 2. So you just have to flat out memorize those. Something that might help you, Pythagorean theorem, that squared plus that squared equals that squared. It has to work on all of these. So if you know 1, 1, 1 squared plus 1 squared is 2, and you get the hypotenuse, you square root that. Another thing that will help you, the hypotenuse is always the biggest number. 2 is bigger than radical 3 and 1, because 2 squared is 4, radical 3 squared is 3, 1 squared is 1. And so here's the pattern. You always have a 1, 2, and a 3. 1, 2, 3, and a 30, 60, 90. But it's 1, 2, radical 3. You know 2 is the biggest, so that's the hypotenuse that has to go there. So the radical 3 and 1 have to be your legs. And if it's a 30 degree, that's a flatter triangle, so it's wider than it's tall. If it's a 60 degree, it's a taller triangle, so it's taller than wide. And the 45, 45, 90 is just 1, 1, radical 2. From that, you can get the sine, cosine, and tangent of these very easily. So I will do those for you. So we know sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent, which is equivalent to radical 3 over 3 if you rationalize that. But I just want to say something. Instead of thinking opposite over hypotenuse, adjacent over hypotenuse, sine is the y, right? Sine is the y, so it's the y over the hypotenuse. Cosine is the x, so it's the x over the hypotenuse. So think of it that way. Cosine, oh, it's the x-coordinate, but I need to make it a unit circle, so I have to divide by 2. Oh, the sine, that's the y-coordinate. Oh, that's 1, but to make it a unit circle, I have to divide everything by 2. So you can get it that way, instead of thinking opposite and adjacent and all that. So we will do the same thing with the 30 or the 60 degree. Sine is the y-coordinate. Oh, radical 3. Oh, cosine is the y-coordinate, x-coordinate. That's 1. And again, because this is 2, to make it a unit circle, I divide everything by 2. And tangent, that is opposite over adjacent, or sine over cosine, or the y over the x. So that one's just going to be radical 3. And then here, for sine, that's the y-coordinate. But I divide by the hypotenuse. Cosine, oh, that's the x-coordinate. And tangent, opposite over adjacent. So that's just 1. So once you can see this, visualize it, or just memorize it, I actually, after all these years, I kind of have it memorized, but I kind of see it too. I actually have a visual in my head when I do these. So in order to be like good at unit circle, this needs to be understood. You have to get that. So next step in unit circle. So first, understanding that the x is the sine and x is the cosine, y is the sine. And then to figure out if it's positive or negative, for the cosine, it's when the x is positive, cosine is positive, so to the right. And when x is negative, to the left, cosine is negative. And for the sine, it's the y. Y is positive above, y is negative below. So that's the second step. Third, you have to know these basic triangles. So in calculus, everything is in radians. We don't deal with degrees. And actually, radians is way easier than degrees. So I want to point something out here. We know 180 degrees is here, but this is also pi. So half of 180 is 90, but half of pi is pi over 2. So it should make sense that that's pi over 2. It's half of pi. All right. Now, if you cut pi in half, okay, if you cut 90 in half, you get 45. If you cut a half of pi in half, you get a quarter pi or a fourth of a pi. So it makes sense that this is your pi over 4. And then let me do the other one. So how do you get 30 from 180? How many slices of pie do you have to make? So 30, 60, 90, 120, 150, 180. That's 1, 2, 3, 4, 5, 6 slices of pie. In other words, 180 divided by 6 gets you 30. So to get 30, you divide your 180 by 6. Okay? So 180 divided by 6 is 30. So to figure out the radians, you just take your pi and divide by 6. So that's quite easily pi over 6. Now let me show you the left side, some tricks for the left side. But watch. 1 pi over 6. This will be 2 pi over 6. But 2 pi over 6 is pi over 3, and we'll get there. So that's 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6. So that's kind of how it works. That's how we're going to get the 5 pi over 6 here. Again, counting 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6. Now, another way, this is how I do it. Well, 1 pi is 6 pi over 6. So if I back up 30 degrees, which is pi over 6, I subtract 1 from that, I'm at 5 pi over 6. And that's really how you should do that. But I'm kind of showing you where these 30s and 60s and all that come from. So I don't want to spend too much time on looking at these other quadrants right now. Just know this is pi. So where does a 60 degree come from? So how do you get 60 from 180? What do you have to slice that pi into? It's 3. 180 divided by 3 is 60. So to get your radian measure, it's pi divided by 3. So you should know 60 is pi over 3. All right, what does this do for me? Now, taking this back to this, big connection, big brain time, realize that a 30-degree triangle is pi over 6. A 60-degree triangle is pi over 3. And a 45-degree angle is pi over 4. This is huge. Anytime you see, and we'll deal with this in a second, a radian measure reduced, if the denominator is 6, it's going to be a 30-degree triangle, and you'll learn this in a second. Anytime you see a denominator of 3, 180 divided by 3 is 60, you know it's a 60 degree. 180 divided by 4, that's 45. That's going to be a 45-degree triangle. So you can replace 30 with pi over 6. And 60 with pi over 3. And 45 with pi over 4. So you get the picture. All right, let's keep going. And I want to explain to you how you get all your other angles and how you figure out where they are. So now you understand where the pi over 6, pi over 4, and pi over 3 come from. It's just 180 divided by 6 is 30, so pi divided by 6 is 30. 180 divided by 4 is 45, so pi divided by 4 is 45. 180 divided by 6 is 30. 180 divided by 3 is 60. So pi divided by 3 is 60. And 180 divided by 2 is 90. So this is pi over 2. Now I'm going to show you how I get all the other ones. So I realize if I'm dealing with pi over 6, here's what I'm doing. If I'm dealing with pi over 6, 1 pi is 6 pi over 6. So if I back up 1 pi, look, 5 pi over 6. If I advance 1 pi, 7 pi over 6. That makes those two really easy. Now what if I'm dealing with pi over 4s? Well, if I'm dealing with pi over 4s, that makes this 4 pi over 4. Now look how easy this is. If I back up a quarter pi, I was at 4, now I'm at 3. If I advance a quarter pi, I was at 4, now I'm at 5. Look how easy it is to figure out which quadrant those are in. And the last one we'll look at here is the pi over 3s. Pi is 3 pi over 3. Watch, if I back up 60 degrees, I had 3, now I'm at 2 pi over 3. If I'm at 3 pi over 3 and I advanced pi over 3, look, I'm at 4 pi over 3 if I advance 60 degrees. That's how easy that is. Now, 2 pi over here, whoopsies, 2 pi over here, that's like, if we're dealing with pi over 6s, that's 12 pi over 6, right? So look how nice this is. Well, if I back up a pi over 6 with 30 degrees, look, I'm at 11. What if I'm dealing with pi over 4s? 2 pi would be 8 pi over 4. If I'm at 8 pi over 4 and I go back 45 degrees, that'll bring me back to 7 pi over 4. And then if I'm dealing with pi over 3s, 2 pi would be 6 pi over 3. Well, if I back up 60 degrees, if I have 6 pi over 3, bam, I reduce by 1, I'm at 5 pi over 3. So that's how you figure out where or what quadrant you're in to figure out if your sine, cosine, or tangent is positive or negative. So that's the next step, knowing the radian measures of all of these. And again, you shouldn't have to memorize all these. You shouldn't have to go, where's 11 pi over 6? That's in the fourth quadrant. No, 11 pi over 6, 11 pi over 6, I know this is 6 pi over 6, and this is 12 pi over 6. Where's 11? It's 1 back from 12. I'm in the fourth quadrant. So there's a quick and easy way of figuring out which quadrant you're in without having to memorize all this crazy stuff. Now, we're going to put all this together. We're going to look at all the 30-degree triangles. These 4 triangles are exactly the same. Exactly. They all are exactly the same. Why am I saying that? Well, the next thing you learned is that the x-coordinate here is the cosine. Well, how long is that? Well, we learned at the pi over 6, the cosine is radical 3 over 2. So this is radical 3. Ooh, that's too fat. Let me back up. This is radical 3 over 2. And this is the same length. It's the same triangle. So that's negative radical 3 over 2. And we know from pi over 6, again, you have to know these triangles. You have to know the cosine and the sine and the tangent for that. So looking at this, we learned that the length of this, I'll make that fatter, that is the sine, but we know that's 1/2. So here, that has to be 1/2. But if you go downwards, that's negative 1/2, and down, that's negative 1/2. So here is the significant thing. If you look at all 4 of these triangles, all the cosines are radical 3 over 2. It just is that if you're on the left side, it's going to be negative. And for all 4 of these, the sines are all 1/2. But you have to realize if you're on top, your y is positive, so sine is positive. And if you're on the bottom, it's negative. So here's the big secret. Notice all four of these, all four 30-degree triangles have a 6 in the denominator. Magically. Yeah, look at this. The only ones that have a 6 in the denominator are the 30-degree triangles. So here's what you should do. Oh, I see a 6 in the denominator. That's a 30-degree triangle. I go back in my head. In a 30-degree triangle, the sine is 1/2. The cosine is radical 3 over 2. The tangent's 1 over radical 3. So all of these sines will be 1/2. All of them. And all these cosines will be radical 3 over 2. You don't have to memorize them. You just have to memorize that for a 30-degree angle, the sines are 1/2. For a 30-degree angle, the cosines are radical 3 over 2. And the tangent is 1 over radical 3 for all those. So you don't have to memorize a bunch of different angles. You just have to know the pi over 6. And I'll show you the rest of my thinking. Here's my next big brain processing. So these are easy. First quadrant, pi over 6. When you just have 1 on top, you are here. Cosine's positive because x is positive. Sine's positive because y is positive. So we know these are positive, and tangent's a combination. Two positives make a positive. Okay, in my head, here's what I see. Oh, 5 pi over 6. Well, I know we have 6 pi over 6 here, so where's 5? Oh, it's over here. And what's y here? Y is positive and x is negative. Y is positive and x is negative. Therefore, sine's positive, cosine's negative. And tangent's a combination, so that's negative. Look how easy that is. Once you know the basics, you can do this. Then we go through the same process. Oh, 7 pi over 6. I know that 6 pi over 6 is here, so 7 must be in the third quadrant. What's it like down here? Y is negative and x is negative. So since x and y are both negative, that means sine and cosine are both negative. But tangent's a combination, and two negatives make a positive, so my tangent's positive. And the last one you deal with, 11. How do you do that? Well, in my head, I know, oh, this is 12 pi over 6. 11 must be 30 degrees that way. It's right there. In the fourth quadrant, x is positive, y is negative. Therefore, cosine's positive and sine is negative. And tangent's a combination, so a negative and positive make a negative. That's how I find the sine, cosine, tangent of anything with a 6 in the denominator. Now, guess what? It's the same process, but now we're looking at a 60-degree angle. So like I said, that length of that x is the cosine. And in this case, it's 1/2, because we know, we've memorized, when we have a 60-degree triangle, or a 3 on the bottom, that we're looking at the 60, and the cosine is x over hypotenuse, and the sine is y over hypotenuse. So that becomes a very simple thing. The cosine is 1, and the length of the y-coordinate is the sine, and we know that one's radical 3 over 2. And because all these triangles are the same, this is radical 3 over 2, this is negative radical 3 over 2, this is negative radical 3 over 2, and this is negative 1/2. So we know for that angle and that angle, the cosine is negative 1/2. For that angle and that angle, the cosine is positive 1/2. For that angle and that angle, the sine is radical 3 over 2, positive. And for this angle and this angle, the sine's negative radical 3 over 2 for both those. So it makes life very simple. So here's a secret. Oh, there are 3's in the denominator for all these. I know that's a 60-degree triangle. What's the sine, cosine, and tangent? Well, from the triangle that we know, the sine of all these is radical 3 over 2. And the cosine of all those are 1/2. And the tangent of all those are radical 3. Got a little crazy there. Little crazy. And then you go through the same process. Well, there's a 1 on top of each of these. First quadrant, everything's positive, done. Now I go through this logic. Oh, 2 pi over 3. Well, I know 3 pi over 3 is here, so 2, I must go back 1. That puts me in the second quadrant. X is negative, y is positive. That means cosine's negative, sine is positive, and tangent is a combination of those. So one positive and negative, make a negative. Oh, what do I have? Oh, 4 pi over 3. I know 3 pi over 3 is here, so 4 pi over 3 must be in the third quadrant. I just advanced one 60-degree angle. Well, I know x is negative and y is negative. That means cosine and sine are both negative, but since tangent's a combination, two negatives make a positive, done. And then let's look at 5 pi over 3. My logic says I know this is 6 pi over 3, so I must move back 1 pi over 3, puts me in the fourth quadrant. Well, x is positive, y is negative. Cosine's positive, sine is negative, and a combination is negative, done. That's your process of anything over a 3. Now, I'm going to go through this one a lot more quickly. I'm not going to draw all the things in here because we don't need to. Now you know whenever there's a 4, you automatically think 180 divided by 4 is 45. So I use the 45, 45, 90, and we know that the sine of all those are 1 over radical 2. Muy fácil. And the cosine is 1 over radical 2 because it's an equilateral triangle. The x and the y have the same length. And the tangent's all 1 because the x and y are the same length, and tangent's y over x. Now, this is pretty easy. A 1 in front of all these means first quadrant, they're all positive, done. 3. Where is 3? I know this is 4 pi over 4. 3 must move back 1. I must be in the second quadrant where x is negative, y is positive. That means cosine's negative, sine's positive, and a tangent's a combination, so that's negative. Then I look at that. Oh, there's a 5? I know this is 4 pi over 4. 5 must move 1 further. That puts me in a third quadrant where x is negative and y is negative. That makes sine and cosine negative, but tangent's a combination, so it's positive. And the last one, 7 pi over 4. Golly, I know this is 8 pi over 4. If I back up 1 to get 7 pi over 4, it puts me in the fourth quadrant where x is positive, y is negative. Therefore, cosine's positive, sine's negative, tangent's a combination, negative, done. That's unit circle. And the more you practice this, the faster and faster you get. Now, we have something called quadrantal angles. Those are, let me make it fatter. Yeah, the angles that are directly on the x and y axis. So how do you deal with that? Well, here's how we do it. What are the coordinates there in the unit circle? Well, we all know that's going to be 0, 1. At this point, the coordinates, -1, 0. Here, the coordinates, 0, -1. And here, the coordinates, 1, 0. This is so easy. We learned in the first part, cosine's the x, sine's the y. So here's 0 degrees, cosine's 1, sine is 0. Look how easy it is. 1 and 0. Now tangent, sine over cosine, so tangent is 0 over 1, which is 0. Pretty simple. Let's do the next one, pi over 2, right here. Cosine's the x, sine's the y. Cosine is 0, sine is 1. Cosine is 0, sine is 1. Tangent is sine over cosine. Dividing by 0 is not allowed. That's undefined. Let's look at pi. Here's pi. Cosine's the x, sine's the y. Cosine's -1, sine is 0. Cosine's -1. Ooh, I messed up on this. And sine is 0. Well, tangent is sine over cosine. 0 over -1, which is 0. And one more, and we're done with the unit circle, is 3 pi over 2. Cosine's the x, sine's the y. Cosine 0, sine's negative 1. Cosine 0, sine's negative 1. Tangent is sine over cosine, which is undefined. And think about this. Tangent is like the slope. The slope of this is undefined. The slope of that's undefined. The slope of that's 0. The slope of that's 0. That is unit circle in a nutshell. Hopefully this helps. Bye-bye.